You know, what if our greatest solutions turned out to be our biggest mistakes? Today, we're diving into a story of chemical marvels that promised to change the world, and they absolutely did. Just not always for the better.
It sounds like the start of a really weird joke, right? But the answer connects some of the biggest technological leaps of the 20th century with some of its most devastating environmental blunders. And the one thing that ties them all together? A single, powerful class of chemicals.
And here they are, polyhalogen compounds. Now, to put it simply, just picture a carbon structure, but it's loaded up with halogen atoms. We're talking elements like chlorine and fluorine. This special structure made them incredibly stable, and that made them absolute superstars in factories and on farms. For decades, these things seemed like magic. I mean, they were solving huge problems, from stopping deadly diseases to just making modern life way more comfortable. But every single one of them came with a catch, a hidden cost that we'd only figure out much, much later. Okay, so let's start with a couple of powerful solvents. In this case, the catch wasn't some far-off problem that took years to show up. Nope, this was an immediate, direct threat to the human body. First up, dichloromethane. This stuff was a real workhorse. You can see the list. It was used for everything from stripping paint off walls to cleaning metal parts in factories. At the same time, you had chloroform, which was just as vital. It was even used as one of the very first surgical anesthetics. That was a massive revolution in medicine. Both of them were just unbelievably effective. They worked so well that they were literally everywhere. But their incredible power to dissolve things didn't just stop at paint and grease. It kept right on working on the human body. So you have to wonder, what was the real price for all this convenience? And here's that trade-off, laid out plain and simple. While dichloromethane was busy degreasing machine parts, it was also directly harming people's central nervous systems, causing things like dizziness and nausea. And chloroform, that miracle that made surgery bearable, yeah, it was later found to cause severe damage to the liver and kidneys. And what's truly terrifying is just how unstable chloroform could be. If you didn't store it perfectly, I mean in dark, completely sealed bottles, just a little bit of air and light could literally turn it into phosgene gas. That's a lethal poison. It's a pretty stark reminder of the dangers that were lurking just beneath the surface. Okay, so now we're about to level up. We're moving from a personal risk, a direct threat to an individual's health, to a long-term threat facing the entire planet. So meet the freons. Seriously, if you were a chemist trying to design the perfect industrial chemical, this is probably what you'd come up with. Just look at these properties. Super stable, totally unreactive, non-toxic. I mean, they were perfect for things like refrigerators and air conditioners. And they were made from another wonder chemical, carbon tetrachloride, which was the go-to for everything from cleaning stains to putting out fires. And because they were so perfect, we made an absolutely staggering amount of them. Get this, by 1974, the world was pumping out 2 billion pounds of this stuff a year. It's almost impossible to wrap your head around that quantity of man-made gas being produced and, well, eventually released. So this leads to the huge, looming question. What happens when a chemical is too perfect, so stable that it just never breaks down in nature? It has to go somewhere, right? And here's where it went up. Its incredible stability meant it just floated, completely unchanged, all the way up into the stratosphere. Once it got up there, the sun's powerful UV radiation finally had enough juice to blast it apart. This released chlorine atoms, and that started a devastating chain reaction. We're talking about a single chlorine atom being able to destroy thousands and thousands of ozone molecules, basically punching a hole in our planet's protective shield. And look, this wasn't just some abstract problem for scientists to worry about. A thinning ozone layer has very direct, very real consequences for every single one of us. It means more of those harmful UV rays get through to the surface, leading to very real increases in skin cancer, cataracts, and even damage to our immune systems. The perfect chemical had accidentally created a global health crisis. And now we come to maybe the most famous and the most dramatic story of them all, DDT. This is the ultimate tale of a chemical hero that became an environmental villain. Just look at this timeline. It's wild. In less than 10 years, DDT goes from being a little-known compound to winning its discoverer a Nobel Prize. But then, almost as fast as it rose, the problems start to surface, and just a couple of decades later, it's banned in the US. That is an incredibly rapid rise and an even faster fall. And you really cannot overstate how important this was at the time. The Nobel Prize was awarded because DDT was shockingly effective at killing the insects that carried two of the deadliest diseases in history, malaria and typhus. It saved millions of lives. It truly was a miracle. So, this is the central question, isn't it? How do you go from winning the world's most prestigious award for saving humanity to being labeled a dangerous environmental poison? Well, here's how. First, the insects started developing resistance pretty quickly. But the real knockout blow came from two key properties. Like Freon, it was incredibly stable, so it just persisted in the environment forever. And crucially, it was fat-soluble. That means it dissolves in fat, not water. So instead of washing away, it got stored in the fatty tissues of animals. Small fish ate contaminated insects, bigger birds ate the fish, and at every step up the food chain, the poison became more and more concentrated. So, after all of this, what do we take away from these stories? Because each one of these compounds, for all the damage they caused, they also taught us some crucial and, frankly, hard-won lessons. You can see the patterns so clearly here. Every promise came with a price. The solvent that eased pain also destroyed organs. The refrigerant that brought us comfort also tore apart our atmosphere. And the insecticide that saved millions of lives ended up poisoning the entire food web. It's the same sobering pattern of unintended consequences over and over again. Ultimately, this is the powerful legacy of these chemicals. They forced us to think long-term. They taught us all that you can't just solve one problem in a bubble without considering the chain reaction, the domino effects that you might be setting off down the line. And that brings us to right now. From plastics in our oceans to AI and genetic engineering, we are constantly creating new miracle solutions. The lesson from these chemicals has never been more relevant. The challenge for us today isn't just to innovate, but to have the wisdom and foresight to ask, okay, what's the catch this time? And can we find it before it's too late?